If your storage account, database, or key vault is reachable over the public internet, a firewall rule is not really enough. In this video, we build one thing end-to-end, a private endpoint that pulls an Azure storage account onto your virtual network so traffic never leaves Microsoft's backbone. I'll cover the architecture, every step in order, the decision behind each one, and exactly what to check when it's working. By the end, you should be able to rebuild this from memory. The single most important part, the part everyone gets wrong, is private DNS, and we'll spend real time there. Here's the target architecture. A private endpoint is a network interface, ANIC, deployed into a subnet in your virtual network, VNet. It gets a private IP from that subnet, and that IP maps to a specific resource, for example, one storage account's blob service. A virtual machine in the VNet then talks to the storage account over that private IP instead of its public name. On the platform side, this uses Azure Private Link to wire your NIC to the service. The result, traffic stays inside the Microsoft network, and you can fully disable public access on the resource. First, the VNet. Pick or create a subnet to hold private endpoints. A common rule of thumb is a dedicated subnet just for endpoints, so network policies are easy to reason about. Note that network security group rules on a private endpoint subnet historically needed a feature flag, so check current docs for how NSG enforcement behaves today. Make sure the subnet has enough address space. Each private endpoint consumes one IP. Keep the VNet in the same region as the workload that consumes it to avoid cross-region hops. Now create the private endpoint itself. You select the target resource, the storage account, then the sub-resource, which is the specific service, blob, file, table, or queue. This matters. Each sub-resource needs its own private endpoint and its own DNS zone. If you want blob and file privately, that's 2 endpoints. When you create it, Azure provisions the NIC, assigns a private IP from the subnet, and opens a connection request that auto-approves if you own the resource. At this point, the plumbing exists, but nothing is using it yet, because clients still resolve the public name. This is the step that makes or breaks it. Your app still connects using the public hostname like myaccount.blob.core.windows.net. With a private endpoint, that name must resolve to the private IP instead of the public one. You do this with a private DNS zone named for the service, for example, privatelinky.blob.core.windows.net. The public name has a CNAME that points into that private link zone, and the zone holds an A record for your private IP link, the private zone, to your VNet, so the VNet's resolver uses it. Best practice is to let the endpoint create and manage the A record automatically. With DN South in place, close the front door. On the storage account, set public network access to disabled. Now the only way in is through the private endpoint. Be deliberate here. Any service that reached this account over the public internet, including some platform features and your own pipelines, now needs a private path or an exception. For hub and spoke topologies, point your spokes at a central DNS resolver or forward the private link zones, so every VNet resolves consistently instead of each team rebuilding zones. Now confirm it. From a VM inside the VNet, run nslookup against the storage host name. The answer should be the private IP from your endpoint subnet in the 10 dot range, not a public address. If you still see a public IP, your DNS linkage is wrong. Fix the zone link before anything else. Then actually read or write a blob. It should succeed. From a machine outside the VNet, the same call should now fail or be refused, which proves public access is truly closed. Finally, check the private endpoint's connection state shows approved. To recap, a private endpoint is ANIC in your subnet with a private IP that maps to one sub-resource through private link. The order is VNet and subnet, create the endpoint, wire up the private DNS zone, then disable public access and verify resolution and connectivity from inside and outside. The one thing to burn into memory, 90% of private endpoint problems are DNS problems. If a client can't connect, run nslookup first. Pricing is per endpoint plus data processed, so don't spin up dozens casually, and always confirm current per service behavior and cost in the Azure docs, because these details change. Build it once carefully and templatize the rest. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.